Alright, next up, we're doing 1-5 notes, arithmetic operations. In this document, you'll be able to have the computer calculate arithmetic operations. You'll be able to have the computer add a value to a variable. You'll be able to use the operator procedure, aka order of operations. PEMDAS is the acronym PEMDAS. You'll be able to have the computer round and find absolute value of a number, and you'll be able to have the computer use an accumulator, aka establishing a total, like a total score in a game. So with that all being said, why don't we do file, new file, Python file. Now let's type in arithmetic, ARITH, arithmetic underscore operations .py. That's just the file name. Now, just like you learned about in school, you know 3 plus 4 equals 7. And 7 plus 9 equals 16, so on and so forth. We could have the computer doing arithmetic. So the little plus sign is addition. You know, 3 times 4 equals 12. Little times symbol in computer world is that little asterisk, which is shift 8 on a lot of keyboards. You know, division sign of 10 divided by 5 equals 2. The backslash is division, if you haven't seen that already in math class. Your usual 5 minus 3. So subtraction is just the regular old minus sign. 5 minus 3 equals 2, duh. Now powers. Let's say you want 3 to the power of 4. Normally in math class we did a little caret. 3 caret 4. Well, in our computer world, in computer science, we do a double star. So 3 caret 4. That would be 3 to the 4th power. AKA 3 times 3 times 3 times 3. And whatever that number is that number. That's how you do powers. The remainder, like if we did 10 divided by 4, we know that's 2 remainder 2. You know, there's 2 left over after we divide. To do remainders, that'd be 10. Let's say we want to do 10 divided by 4. That's when you use the little percent sign. Find that out. Now if we want to print that all the answers to the console, that's when we actually use print. So let's kind of do that same thing but with print. So let's say print, I want to print the answer to the console. 3 plus 4. Well, we know that's 7. So run, we're going to run our arithmetic. Yep, there you go, there's our answer of 7. So we had a computer do that for us. Let's say we wanted to do 10 minus 4. And that little print. Look at that, 10 minus 4 gets you 6. So that's addition, that's subtraction. Let's do multiplication. 10 times 4. You get 40. Division. We gotta make that nice and pretty. Let's go 10 divided by 5. You know we get an answer of 2. That does 2.0, that's nice. Let's say we do a remainder. So 10 percent sign 4. Well, we know 10 divided by 4 is 2. And then what's left over is actually 2. So that's left over, that remainder is the 2. Let's do another example. Let's do 10 divided by 3. You know that's 10 divided by 3 is 3.3333333 on a calculator. AKA it goes in 3 times and then there's a remainder of 1. So we should have a remainder of 1. Hence why a 1 appears on the printout on the Python console, the printout screen there. And then powers. 10 to the power of 3, aka 10 times 10 times 10. That'll be 1,000. Hence you get a printout of 1,000. Why don't you try the you try 1 in your notes and you try number 2 in your notes. Get those done and uploaded. And next we'll talk about adding a value to a variable. All right, good job. So let's do adding a value to a variable. So let's go File, New, Python file. I'm gonna say add underscore sub, we're gonna do some subtracting too, val to a variable .py. I abbreviate a little bit, feel free to abbreviate. These notes are for you to look back on. So let's say our x value is 20. Our y value is x plus 3. We're using some substitution that we learned about in Algebra 1. We're going to replace that x with the number 20, and we're going to print out our y value. In other words, what the result is, we're substituting some numbers in. We're adding a value to a variable. We're adding that 20 into that variable x. So let's make sure we run the right program. And look at that, 23 is what appears. So 20 plus 3 is 23, hence why 23 appears there. Let's say we change it up a little bit. We say x is 20. Replace inside that y value. I want to print out x. I'm going to say x plus 3. And I'm going to print out the x. What do you think is going to happen? Well, let's run it. Let's find out. 23. Why did it do that? Well, it took that 20 and put it in for the x there. And then 20 plus 3, I'm still printing out this variable. It prints out, recognizes the second, the replacement variable. Sometimes in code that gets very confusing with people. I try to avoid doing that as a person. However, with some of your coworkers, they're going to just do that because we know that this variable is connected to this variable. And this x value is connected to this. I personally like doing, as a mathematician, changing up that variable while teaching, so you guys can easily identify that y gets connected there. And you still can do x and x. Let's change up the operations so you see with some different operations. So 20 goes in, 20 minus 3 gets you 17. 20 times 3, I bet you know that's going to be 60. And let's do power. Instead of 10, let's do 5. 5 to the power of 3. 125, because that's 5 times 5 times 5. Just like you did in algebra class. Cool. Why don't you try number 3, and then we'll move on to order of operations, aka operator procedure, aka PEMDAS. Let's go File, New, Python file, order of operations. .py. And we're going to practice our order of operations. So you have to be familiar with your graphing calculator or a calculator and how it works. So let's say we got a whole problem here. 10 plus 3 times 2 to the power of 2. So that's our problem, and we want a computer find and calculate our answer. So we do print, and I want to print out that x variable, the result of it, when it's all combined out. So we type our equation in, we make sure we run the right program, order of operations, and we get a result of 52. Now we have to know our inverse operations, or our order of operations. P for PEMDAS stands for parentheses. That's what we have to take care of first. So 10 plus 3 is 13. Then we got to take care of exponents. So 2 squared is 4. So then it's going to be 13 times 4, which gets us to 52. It's not 13 times 2, 26 to the second power. No, 26 to the second power. If we delete the parentheses, we're not even going to get that. When I delete those parentheses, we're going to do a 10 plus 3 times 2 to the second power. So if we're doing order of operations here, 2 squared is 4. 4 times 3 is 12, and 12 times 10 gets you 120. I guess 22, pardon me. Yeah, 2 squared is 4. 4 times 3 is 12. 12 plus 10. Sorry, my eyes are trouble seeing that. That's actually a plus sign. 10 plus 12 gets you 22. So order of operations will always be correct on the computer. We have to make sure we type in the correct equation into the computer. All right, why don't you try number 4 in your notes. And we're going to talk about rounding an absolute value of a number. We're going to do that now, next. So let's do file, new, Python file, round underscore, and absolute, for absolute value. Alright, so let's say we got a number stored in a variable. Let's say 2.9134 24 ... I'm not gonna actually put the dots in there. Let's say we do print, and we want to round. As you probably would expect, the keyword is round, and I'm gonna round that number that's stored in the X value, just like that. And when we round that number, it rounds it to the nearest integer, which is 3. Now what if I wanted to do not that variable X, but I want to do a different number? Well, we could type in that number right in here if we wanted to. Also, we're going to round that particular number, and it's 6. So 5.7 rounds up to 6. Let's say I did 5.2. If you round it correctly, that should be 5. So you could have it up here, you could store it in a variable and then print out the variable and round that variable, or you can literally type that number right into it. Either way is acceptable. Or I was rounding the number. Now let's say we want to do the absolute value. So let's say we did that round. We want to do absolute value. Well, absolute value is ABS, is a little keyword. Let's do the absolute value of -5. This is in fact not even needed. So print, what's the absolute value of -5? Well, that would be 5. What's the absolute value of -12? That would be 12. What's the absolute value of +12? Well, the number is distance from 0, so that's also 12. So that's absolute value. Yes, you could also store a number in a variable. Let's say -7. And we want to find the absolute value of that number that's stored in the variable. We could do that too. AKA my variable is X this time. And I crunch it out and I get the number 7. Why don't you try number 5 in our notes. And then we'll move forward to the accumulator. Alright, here we go. So let's do the accumulator. File, new, Python file. I'm going to call it add to a variable. AKA we're going to keep adding to a variable, as you're going to see right now. We're going to add to a variable. Let's say your total bank account. We all know money, so total bank account is equal to $0. I got no money in my bank. I'm gonna make a little note. This is accumulator. So let's say we want to first print out how much money is in my bank onto the console. I type in first few letters, and then if I hit the tab button, it'll probably print out the right word. It'll show highlighted little pop-up window for you, so you can hit tab. So if I wanted to print out my bank account, you can see it's $0. But let's say I want to actually add some money into it. We are going to. We're going to literally just put another variable in. Let's say the variable add. Now I'm going to add $18. And then we're going to print out, once again, a total bank account. So we do that. Oh no, why didn't it work? Oh well, I just stored 18 in a variable called add. We actually got to now add it to the total bank account. So we got to go total bank account is equal to our total bank account, the original number, plus the added amount. And when we run that, the first printout statement right here is the total bank account number when we originally had it. Then we're going to add the $18, which is what we're doing right here in this line right here, line 4. And then we print it out, the total bank account. And that's why we got the $18 right there. So if I wanted to add $100, we got $100 now in our bank account. Let's say we don't want to have the original bank account. We just want to find out what we added. Oh, I'm going to hashtag out that first print statement. So only the second print statement appears. So it'll be $100 in the account. And we could also add some strings into it to make it nice and pretty. So let's do that. Bank account is 0. I'm going to delete this. I'm going to say this is the original amount of money in account. Close my quotes. I do my little plus sign. That's the total bank account. And then in this print statement, I'm going to add this string in here too. This is the total amount of money in your account after your deposit. Because we deposited or added $100. So let's run it. Oh, we gotta write integer because we're working with integers. Pardon me. Oh, pardon, I gotta change this into a string, not an integer. Because since we're printing out a string, and a string, convert our numbers into a string and look at that. Oh, what's that little space? Make it even prettier. Add one of these. There we go. Now it looks a little bit better. Or is it in your account? And we continue. We can continue add to it. We can also subtract using our operations, our mathematical operations. Now, could we also say this? Let's find out. Instead of saying string, we could use this little character, and we could also say function, like we practiced a little bit in the previous lesson. If we do a little function with that, that can make it all work too. So there's two different ways. String literal. That's because I forgot to add this here. There we go. So this is the total amount of money in your account after the deposit. We can actually delete these. Alright, since time is up, why don't you do try number 6 and I'll be all lit. Have a great day.